kind of just like changing the context of it. The images are still going to work, but I'm making the context a little bit less weird because they did weird. So we're going to wind up eventually looking at the graphs on page 103, but we're going to start just looking at these images up here. Because yesterday what we did is we took samples of that set of rectangles over and over and over again. Each one of us did a sample so that we could find, ideally, the average of everything. And it's my turn to talk, guys. So what we're going to do, and the reason we have things like that is because if instead of us having 100 rectangles on a page, because we could do 100 rectangles and average that out, what if it was 1,000 rectangles? Or 1,000,000 rectangles? Or one rectangle for every American? That would be a lot harder to find the actual average of, which is why we take samples, is so that we can compare what we get with what we anticipate the entire population. Like, say, all Americans or every student in Pike High School. I'm not really going to actually ask every single person. So we take these samples to try and make predictions about our entire population. So what we're going to do today is we're going to compare what we expect results to be with what results we got to see if they make sense, basically. So it's what data scientists do. So I've got a couple of spinners up here, which if I took a thing and just like spun it, we could absolutely spin this spinner and see what is the probability of it landing on pink. What would be the probability of this spinner landing on pink? How'd you get that? Not saying you're wrong, but how? 3 out of 5. We have 3 out of 5 sections that would get this to land on pink. So we would expect this one to have a 3 out of 5 probability. This is not in your book. This is me modifying things in your book. Or, as a percent, we'd say this should be about 60%. What about for the other spinner? What would we expect this spinner to get if I spun it as an average? Yeah, it would be about a half. What would it be as a percent? Or 50%. So we expect our data to kind of show up as if they were all equal. So then my question is, if I spun them 1,000 times, so I just sit here and I spin it and I say pink, not pink, pink, not pink, pink, not pink, and I get 45% pink when I spin it 1,000 times. Which spinner do we think I'm using? If I got 45%. Or is it broken? Is it possible to get 45% when I spin it? On either. I mean, when we're actually doing these, so I spin it, we get pink, there's 1. I got a gray, so we're at 50%. And now I got pink again, so I'm at 75%. 60%, sorry, 66%. I got 2 pinks out of 3 spins. I got 66% on it. I'm over 45. I'm over 50. So it is possible to get any other variation. Since we're doing it by testing, randomness happens. Weird happens. So is it possible for us to get 45% on either one of these? Yeah. It's possible. Which one would it be more likely for it to happen on? For me to get 45% pink? The left one or the right one? Which one would I be more likely to catch 45% in the pink part? The right one. Because 45 is not that far off from the gray. Like if I had my spinner and instead of it being super duper equal, instead I had it kind of like this, then we would expect it to get about 45%. So it's pretty close. If I had this one that I expected to get at 45%, it wouldn't be quite as likely. So the reason I ask it like that is because if look at those graphs on page 103. And I asked us to figure out which graph went with which spinner. What do we think would happen? I'd say I gave those two spinners to 150 people and had them spin it 100 times each. And say, I got this percent of each. Which graph would go with our 50% spinner? Which graph would go with our 60% spinner? What do we think? I was going to say, they're in your book, it's top and bottom. And remember, we had a 50% spinner, so we had one that was...
It also kind of says it about...
You, hush you.
Oh, you don't like the fact I saw that?
I know you saw it. So we've got our 50% spinner and our, there we go, ish, 60% spinner. So my little sketchies of what they look like. I'm so good at art, guys. Woohoo! I'm so good at art. Those definitely look like 50 and 60%, totally. Y'all, this is why I don't draw stuff.
That's why your favorite teacher do it.
And my husband has a visual art degree.
You should make him just sit in here and just like draw all the things for you.
He has a real job too. But he has a degree in fine art. But no, like I'm saying, he has a real job. He goes to work. So which of these graphs do we expect to match with which table? I'm so good at talking too.
No, hablo inglés.
No, she did it.
Because we're not paying attention. Even a little.
Why does it say, it doesn't say it on the board. But why does it say population portion?
Oh no, you
I
wiped
whited it out.
You whited it out. Yeah, I was going to say it was up there. That's how I knew.
I know, I whited it out.
So we
Because I
said.
knew the second I put that up there, you were going to spot that.
Yeah, I spotted and then you wiped it.
That one wasn't good enough. Did you understand what? Yeah, I'm with you. I think this left one probably goes with our 50% spinner because if you look, the average here is really close to 50. So the more times we repeat an experiment, the closer it should be to the true average of the population. So if we were looking at that 45, the chance that I was spinning 45%, it's within just a couple of spaces here. So if I had this properly in CODAP, and I could put up our standard deviation, it would be about here. Would be about where our standard deviation was, that width away from our mean. On the right-hand one, that probably goes with our 3 out of 5 sections being pink, or our 60%. The average in this data is more around here. Somebody have like a find your headphone sound on. There is a ringing. So somebody's phone is making a very high-pitched ringing noise. No, because they don't actually turn that on for us. Yeah, it sounds like one of those either millennials can't hear it sound things or find my headphone. Oh, it's your fan.
Oh, it was?
Yeah, it was your fan because it changed when you picked it up. It changed tune.
Is that what you're talking about? No. I can still hear it.
It's not the rattle.
Oh.
There's a high pitch.
Oh, the hum it like the.
You don't hear it?
No, I don't hear it. I don't hear it either.
It's there.
It's gone.
I was gonna say it's a lot quieter, but I was like, but it's there. I was like, I promise. I was like, the only other. The only time I hear that noise is when my husband loses his headphones and he goes on the YouTube and plays the Find My headphone noise, where it plays the really loud, high-pitched noise. Because he loses his headphones constantly while they're still connected to his phone. So on this one, we can see that our data is very centered around a higher number. It's centered more around 60. So on this one, if I could put my standard deviation up, it would probably be around here. And the likelihood of me getting data back that says 45% is a lot lower. Of my people that did this experiment, I didn't have anybody that got 45%. I had somebody at about 46, so I had somebody close, but I only had one person even close to 45%. Whereas in this one, I had a bunch of people actually get right on 45%. So that is why we have to do repeated sampling, because sometimes we do get data that's way down here. So if I just did this experiment one time and I went, oh yeah, 45%, that totally fits with what I got. That doesn't mean it's exactly right. We have to repeat experiments in order to be able to say for sure what's going on. So if I was to try and do this experiment and see which one was more likely to have a 45%, I would need to do it over and over and over and over again. Okay? So what we're going to do next is we're actually going to try and make a prediction. There's a whole story on page 104 that is chaotic and weird. So I've made a new thing, but using the same graphs. So, originally I had us play that game, but honestly, we don't listen enough to do the game. So, we're not going to do it.
What? The Pack High School?
No, the pulling coins out of a pouch or pulling it's pom-poms out of a cup. And trying to figure out how many of each color there are in there. It's the story on page 104. I usually have us play that game, but we are not of a mental state to actually do that game in here because we don't listen. There are a few, but in general, I would not get enough people participating to have decent statistical data.
Unless that person
Well, when it's sit down when you get the colors. So, what we have here, a story.
As long as you're happy.
So y'all clearly just want me to stand up here the whole time.
No. You showing me his girl. I don't know why.
I was gonna say that's
As long as you happy, bro.
irrelevant to anything that we're doing.
I do.
You can always, have your book out, and that would imply that we should be doing things.
I don't have
the only person who didn't.
today.
So if I went up to 100 people and said, on a scale of 1 to 50, how satisfied are you with Pike High School?
You said one
I said,
1 to 50.
if the teachers were involved, it's like
a one.
To be fair, 1. Did I ask y'all your opinion?
Yes.
No, I did not. I said if we did a poll of 100 people, I didn't see that had to be students. They don't have to be teachers. They could just be people that live in the district. And we do that to 100 people over and over and over again. Which of these graphs might match up with the data that we get from asking 100 people over and over and over again if the actual people that we asked said about 30? So if we wanted to say that people who live in the district would give the school a 30, how would we expect our data to look? And I know the numbers are super tiny up here. The graphs are on page 105 in your book. So ignore the labels, but you can look at the numbers.
Yeah, would be B.
So you said
B, maybe C.
it's more. So wouldn't it be?
Yeah, I'd say B, but maybe C.
Because if
If-
it's supposed to be 30, then it should be. I mean, not B. D.
I was gonna say, The ones that have so 30 is right there, and there, and there, and there. So if we expect our population to say 30, we should expect our graph to look like this. Would it be likely that someone did this survey and got 50 as their answer?
No.
No. Even if we had this graph, our very highest one up here, it is really unlikely that they had an answer of 50. Their survey is also very close together, very tight. So it's a pretty good sample that they have. Everyone they asked, all 100 people, gave very similar answers. Right around 26, 27? But what they did was they averaged their responses. We took, one person said 50, one person said 22, one person said 46, one person said 0. And they averaged them together. So this is averaging the averages to find out what the population might be thinking about everything. So when we are dealing with big groups, large populations, it's not that we necessarily talk to every single person in the population. We're taking samples because logistically it makes more sense. But sometimes we have to repeat them over and over and over again. A lot of places where you see this, where this kind of data will get pulled and used, is in things like political polls, where they'll ask you either right outside the polling place, which always feels questionable to me at best, or they'll stop you in the food court at the mall. Those people with the clipboards and say, do you have a second to talk? Do you have a second to talk? Do you have a second to talk? They're either selling AT&T or they're doing a poll for something like this.
18.
As AT&T is the one that's most common that I see all the time. There's Walmart too. But that's what they're doing. They're taking samples of people, and they'll do that over and over again at malls across the country, trying to get a sample of people across America. So they'll ask 100 people in Indiana, 100 people in Illinois, 100 people in Alaska. They'll just take samples all over the place. And in fact, they'll probably do 100 people in Indianapolis, and 100 people in Fort Wayne, and 100 people in Greenwood, and 100 people in
Or 100
everywhere.
students, 100 staff, 100 parents.
Yeah, or if it's for Pike Township, they could do 100 students, 100 staff. It would be a little biased weighting. More likely what they do is they go down to Kroger, Aldi, gas station.
Well, that could also be its own poll, too.
Mm-hmm. So it's a matter of repeating samples to try and figure out what your whole population wants, because the logistics of asking every resident in Pike Township, that alone is too many dang people to talk to at once. But if I want to know what Americans think about the current, let's say, political climate, not only would that be obnoxiously large numbers of people to talk to, divisively on the phone, everybody's going to yell at me. By the time I got answers from the last person, the first person may have changed their mind, or it's like 3 years later, just because I don't have the time to call every single American for every political opinion. That's just not a thing that's likely that we can do. So we take these samples, but we have to be able to read them, and we have to know how to read the data. So if I do this one time and I got that answer of 30, yeah, D is the most likely, but what other one could I have gotten? What other graph works kind of with the 30 being a result? Which other one would that make sense in? Let's see. Because maybe I just happened upon a whole bunch of people that thought really highly of the school, but the actual data is here. So if I only asked my questions one time, maybe I did get 30. Maybe it's right on here, and it matters how many times we ask that question. So maybe I divided my groups wrong. Maybe I had a biased question.
Or maybe somebody got annoyed that you kept asking.
Maybe someone was annoyed I kept asking, and so they gave zeros. And they pulled the data downwards. Or maybe someone was like, oh my gosh, I can tell you work there, let me give it a 50. Or, oh my gosh, you're my favorite teacher, I'm going to give you a 50. So, there's reasons things can be shifted from there. So C or D would work. It's more likely to be D if we get 30 over and over again, and for my population to think that. But it's just one of those things that we don't really know unless we ask absolutely everybody. We're making an educated guess. And so when we are looking at that kind of stuff and looking at polls, a lot of times they'll talk about things like margin of error, which is actually what we're going to talk about tomorrow. Looking at margin of error and things like that and kind of estimating what that's like. But what it kind of is, it's very similar to, and this is probably going to bother you, it's kind of similar to standard deviation, where it takes our average and it's like the wiggle room on either side of it. And so we're going to talk about that a little bit more tomorrow and how that works and how we can kind of visualize a margin of error and see what that's like when we're looking at repeated sampling. And so we'll do those kind of things tomorrow. But honestly, this one is a pretty short day, mostly because I was 95% sure that we would not be listening enough to do the game version. Oh, the page 106, 107, 108 game that they talk about using this kind of stuff, but you don't listen well enough for that, so we're not doing that.